That's that on that. The first question we have here is solve the following first order differential equation. Solve the following first order differential equation. Okay, and we have the first one, the y, the x is equal to minus x, your brackets open, 1 plus y squared over y times e to power x squared. Okay, please, as you are coming in, just begin to type hello, hello, and subscribe straight away. Separable differential equation is of this form. The y dx is equal to f of x times g of y. That is the format for separable differential equation. Okay, and if you look at what we have here, you can see the y dx. Okay, then again you have two separate functions here. You have x and y. Okay, so what we are going to do in this aspect is to separate the variable, bring the y to one side and bring the x to the other side, and then after that we do the integration. Okay, for the format we have here, you remove this one from here, and that will be what? 1 over what? G of y dy, and then this dx will leave this place, and that will be equal to what? F of x times what? Dx. Separate the variable. This is 1 plus y squared over y. Let's isolate that one. Let us isolate the function y. Then the second one is what? Is minus x over what? E to power what? X squared. This is your dy, dx equal to. Step 2. Let this function y, let it leave this place. Remove the function y from this place. And if you want to do that, this is a fraction. So by the time it goes to the other side, it's going to flip upside down. So we are going to have y over 1 plus y squared dy. Okay, then also allow this dx to leave this place. Allows this dx to leave this place to go to the other side, and that will be equal to what? Minus x over e to power what? X squared dx. So we have succeeded. We've succeeded to separate the variable, to bring the y to one side, and also to bring the what? The x to one side. We have isolated the y variable to one side, the x variable also to another side. Then after that, introduce your integral sign. Introduce your integral sign. Then the next thing to do now is to look at how we can do this integration. As you're coming in, begin to type hello, good morning. Give the videos a thumbs up. Don't stop there. Begin to share the links of this video across your social media platforms. Let's go on. How do we integrate this one? You have integral of y over 1 plus y squared. What we do is very simple. We are going to look at the derivative of this denominator, derivative of 1 plus y squared, which is what? Which is 2y. Want to force it, want to make it to be equal to the numerator. So I'm introducing 2 to this place, and these 2 are introduced. I need to cancel it outside the integration. That is the manipulation we have done in that place. We introduce 2 so that the derivative of the denominator will be equal to the numerator. And in that case, that will be equal to natural logarithm of your denominator. Natural logarithm of your denominator. and don't forget the half by that side, equal to. For the second part, we're going to use change of variable. Let's call it x squared, and then get your du. Your du will equal to 2x dx. And you can see at the numerator here, you have your x dx. So I'm going to make x dx as the subject. So I'm having now du over 2 equal to what? Equal to x dx. So anywhere I see x dx, I'm going to place the u over 2 in that place. So I'm going to clean this place and make the substitution to that. So I have now, that will be equal to integral of, let's take this minus to the outside. That'll be minus outside the integral sign. Then x dx is what? Is du over 2 over e to power what? S squared is what? S squared is u. So that's what we have in this case. And I want to say also, for this module, for this engineering course, if you need one-on-one, okay, or you need a group discussion, you can check my channel, check my email, and send me your request. And from there, we can take it up. We can meet on different platforms, on Zoom and other platforms. Okay, so that you can be tailored to your course, to your material. Okay, one-on-one, group discussion, executive one-on-one. Book your place right now. Thank you for doing that. Minus integral, these two, we can take it outside the integral, and that will be 1 over 2 du. We can also raise this e to power u. We can take it up, and that will be e to power minus u du. Okay? Welcome. I want to say at this point, you are at the right place and at the right moment. You are at the right place at the right moment. What you can do now, if you are coming in, if you are new on the channel, please give the videos a thumbs up, subscribe to the channel, okay, and begin to type your comments. Finally, share the links of this video across all your platforms. Begin to do it right now. Okay, begin to do it right now. Thank you for doing that. Okay, so from where we are now, we now have 1 over 2 natural logarithm of 1 plus y squared equal to, don't forget, when you have integral of e to power u, same function, but there is always an exception. You will need to divide by the derivative of that power. So in this case now, it's going to be minus half the integral of e to power minus u is going to give you that same function. Then you divide by what? By minus 1. So this one become what? Become plus. And that's what? Plus c. And that is the answer to these questions, to these first order differential equation. We have the y, the x equal to y times x, y cubed minus 1. Okay? The question now is that, what is the format of this differential equation? What method are we going to use? Before I will answer that, let's expand this equation. So this will be equal to the y, the x. This one, y times xy cube. That will give us what? Y, x, y 4. And then minus what? Minus y. Okay? Then what we can do again is to move this minus y to the other side. Move the minus y to the other side of the equation. So we have the y, the x, plus y equal to what? Equal to this x times y to power 4. Okay? So if you look at this equation critically, if you look at it very well, you realize that this conform to the y, the x, plus p of x equal to q of x times what? Times y to power n. And this is what we call Bernoulli differential equation. This is what we call Bernoulli differential equation. And then for Bernoulli differential equation, the n must not be equal to 0. If it's 0, then the equation becomes linear differential equation. And if we check the question, our n in this case is what? Is 4. Okay? Then the next question is, how do we solve Bernoulli differential equation? Okay, you can check the channel. I think we have solved a lot of questions on Bernoulli differential equation. Okay, so step one, remove this y to power 4 from this place. So divide the equation by what? Y to power 4. And that will now become what? Y to power minus 4, the y, the x, plus this one here is having 1. So 1 minus 4, that's what? Y to power minus 3 equal to x. So that's that on these aspects. This is where we are now. Then the next thing to do is to let v be equal to what? Y to power minus 3. Call this equation maybe star 1. Make it star 1. Then differentiate this one implicitly. Differentiate implicitly with respect to x. Differentiate implicitly with respect to x. So if you do that, we're going to have the v over the x equal to minus 3. You know, the power will go to the front. Then the function again minus 1. So minus 3 minus 1 minus 4. Okay, the y, the x, the y, the x. Okay, the y, the x. So call this one also. Make this one 1. Make this one star 2. Times what? Times minus 3. Multiply this equation by minus 3. Multiply this equation by minus 3. So if you do that, we're going to have minus 3, this one times minus 3. So we have this, the y, the x. This one also times minus 3. We have what? Minus 3 y to power what? Y to power minus 3. And finally, we have what? We have I hope there is no mistake there. So this one will give us what? Minus 3x. So that's what we have in that case. So that's what we have in that case. So coming in, begin to type your question. Begin to type your question. So coming in, begin to type your question. Okay, everything is in order. So coming in, begin to type your question. So that's what we have now. Okay, as you're coming in, type, begin to say I. Okay, say I. and give the videos a thumbs up, show likes, show love to this video. Oh, I can see you. Thank you, thank you, thank you, thank you. Thank you for coming on board. Thank you for coming on board. Okay, begin to type your question and share the links of this live section to your friends on your social media platform. Thank you for doing that. Thank you for doing that. So this is what we have now. This is what we have now. Thank you, thank you, thank you, thank you, thank you. Thank you for coming on board. Oh, hello, thank you, thank you, thank you, thank you for coming on board. As you are coming in, begin to say I. I can see you. Thank you for coming on board. Thank you. So this is what we have now. The next thing to do now is to begin to make substitution. Plug in your *1, plug in your *2 into this one, into *3, asterisk 3. Plug in, make substitution. So this one will be equal to what? That's *2. That will be the v dx. That will be the v dx. Okay? And don't forget your y to power minus 3. Your y to power minus 3 is what? Is v. So we're going to have minus what? Minus 3v equal to what? Equal to minus 3x. So in this case now, this equation is linear. This equation is linear in v. This is linear in what? In v. And once it's linear in v, then we solve it in linear differential. This is linear in v. Okay, this conform to this conform to the y, the x plus p of x y equal to what? Equal to q of x. So in this case now, if you correspond this standard equation of linear differential equation to this one, your p of x is equal to what? Is equal to minus 3. That's your p of x. Okay. Then the next thing to do when your equation is linear, the next thing to do is to get the what? Integral factor. Get your what? Integral factor. And it has this symbol. This is the integral factor, which is equal to e to power integral of p of x dx. And make the substitution. That will be e to power what? My p of x is what? Minus 3 dx. And that will give me e to power what? E to power minus 3x. That's my integral factor. That's my integral factor. Welcome, welcome, welcome. As we are coming in, just begin to type I. Say I and show love to this video. Show love to this video. Type your question, say something. I like your energy. Oh, this is excellent. Say something. As you are coming in, begin to type your comments. Type your question. Okay? I can see you. You also can also say, I can see you too. I can see you. You can see me. Okay? Subscribe to the channel. Subscribe to the channel. Thank you, thank you, thank you for coming on board. Thank you for coming on board. You can book an appointment for this course. This is engineering maths, okay? And we are looking at first order differential equation. And under this aspect, we are looking at separable differential equation, separable techniques, Bernoulli, and what? An exact differential equation. And what we are doing in this section is solving question. We are solving question. Okay? We are solving a new question. Actually, the foundation to this topic has been made. You can check the video the other live section for this topic. Check my channel for what? How to solve separable differential equation. Okay, check the live section, check the channel, and then you go for more elaborate discussion on this topic. I want to say you are in the right place, and as you are coming in, begin to say hi, show love to the video, and begin to share the links of this video across all your platforms. Make it go viral. Okay, the more you do that, the more the YouTube algorithm will push this video to a larger audience. Okay, and that is one of the ways to advance, to support this channel. Thank you for doing that. And as you're coming online, this is not movie. You need to take your journal, your pen, and begin to follow along with me. I'm not dancing here. Okay, take your journal, take your pen, and begin to follow along. Okay, thank you for doing that. The general solution is y equal to 1 over the integral factor. This is the integral factor. Then open your brackets. Okay, integral of integral factor times q of x, and then dx plus c. Then close the brackets. That is what we have now. My q of x from here, my q of x is what? Is minus 3x. The integral factor is there. Let's begin to substitute the integral factor and q of x, and that will be equal to what? 1 over e to power what? Minus 3x. Open your brackets. Integral factor e to power what? Minus 3x times q of x. That's what? Minus what? Minus 3. And then dx. And then plus what? Plus c. Let's not forget, distance is not a barrier. Okay? You can make your request for executive one-on-one discussion on engineering maths, or calculus 1, calculus 2, calculus 3, or calculus 4. This calculus 4 is also called engineering maths. Okay? Check my email and send me your request, and then we can what? We can have one-on-one or group discussion. Okay? Thank you for doing that. I'm going to let u be equal to minus 3x. Let u be equal to minus 3x. Okay? And then the u is equal to what? If you differentiate u respect to that function, you're going to have minus 3 dx. Okay? So I'm going to make a kind of adjustment, okay, to what we have here. This is e to power minus 3x. Okay? I'm coming. Yep. Can we make u is this? No, with that one, will it work? Because I want something to cancel from this place. Okay, I want something to cancel from that place. U is this, and the u is minus 3 dx. Okay, minus 3 dx. It won't work. That will call for integration by parts. As I'm coming in, begin to say I. Okay, I to the I on the comment section. Say something. Okay, say something. I want to appreciate you for coming at this hour of the night. Thank you for coming on board. Okay, tell your friend also to join this section. Share the links of this video across your platform. For the returning viewers, I want to say kudos to you. Thank you for always coming on board. Begin to share the links of this video across your social media platform. Don't stop there. Type your comments. Show this video a thumbs up. Thank you for doing that. Thank you for doing that. Okay, thank you for doing that. Thank you, thank you, thank you, thank you. Let this video go viral. Let it go viral. It's highly achievable. It's achievable by your support. Okay, by giving this video a thumbs up, by sharing the links of this video across all your social media platform. Very possible. Okay, you can make it happen. Make it go viral. Make it go viral. Okay, thank you for doing that. Thank you for doing that. Thank you for doing that. Share the links across your social media platform. Share the links across your social media platform. Thank you, thank you, thank you, thank you. Thank you, thank you, thank you for coming on board. The change of variable, I don't think is working. We're going to use integration by parts for that. We're going to use integration by parts for that. And that will be equal to, we're going to make this one to be u. U is equal to minus 3x. So the u is equal to what? Minus 3 dx. Then the v will be equal to what? E minus 3x dx. So integrate this one, integrate this place. So you are having v equal to what? E to power what? Minus 3x over 3. Then let's substitute that into that equation. Substitute that into that equation. So we have y equal to e to power 3x, open your brackets. For integration by parts, I'm using this formula uv minus integral of v du. Okay, my u is what? My u is minus 3x. My v is what? My v is this one, e to power minus 3x over 3 minus integral of v. My v is this one. This 3 can come outside the integration, making 1 over 3. Then e to power 1, minus 3x. And then the u is what? The u is minus 3 dx. Okay? And don't forget your plus c in this place, plus c. We have minus e to power minus 3x. Okay? Minus 1 over 3. Okay? This 3 is a constant. You can go outside the integration. That will be times 3. And then the integral of e will be that same function. That same function. When you differentiate, when you integrate an e function, it's going to give you that same function. But you must divide by the derivative of that power. By what? By the derivative of the power. And derivative of minus 3x is what? Is minus 3. Okay? As simple as what? As ABC. It's as simple as ABC. As you're coming in, begin to type your comments, give the videos a thumbs up, show love to this video, and share across your social media platform. Thank you. I can see all of you, and I appreciate that. It's not taken for granted. Okay? It's not taken for granted for coming at this hour of the night. Thank you once again. Okay? What you can do for me now, begin to subscribe straight away, type your comments, and share the links on all your social media platforms. Tell your friend right now to join this live section. Okay? And the privilege of this live section, you can talk to me, okay, one-on-one. can type your question and I'm going to respond to it right now. Send your question right now, I'll respond to it. Okay? And if you want to tailor this particular course to your own course, if you want to tailor this engineering math to yours, you can book one-on-one. This time is not a barrier. Okay, check my email and let's discuss, make a request. And then we can see either on Zoom or any of the platform. Okay, thank you for doing that. Thank you for doing that. Thank you for doing that. So that's that on this integration. Don't forget the plus C. Don't forget the plus C. Okay, that's that. What we need to do now is just to tidy up the integration. That's the answer. Just for us to tidy up. Okay, I will leave that one for you. Please do that now. Tidy up this answer and put the final conclusion on the comment section. Okay, put the final conclusion on the comment section. Do the tidy up, okay, and put the final conclusion on the comment section. Okay, so that's that on this particular question. On this particular question, okay, Bernoulli differential equation leading to what? Linear differential equation. Okay, and don't forget the step taking. The step taking is very simple. Once your first order differential equation, okay, once it follow the format of Bernoulli differential equation, then you need to follow the procedure. Everything is governed by rules. Then you follow the rules of Bernoulli differential equation. Okay, once you do that, it will lead to what? Linear differential equation. Then after that, you get your integral factor. And finally, you get your what? General solution. Okay? It's as simple as ABC. But it's not as simple as ABC. Nothing comes by chance. You need to keep practicing. The more you practice, the more it becomes simple as ABC. Practice make perfection. Okay? You need to solve as many questions as possible. Okay? And I want to tell you, if you are coming live, I'm not dancing here. Take your journal, take your pen, and begin to write along with me. Begin to make a jotting. Okay? As you are writing, some of what you are writing will sink to you. You get understanding faster. The more you write, as the speaker is talking, the faster the assimilation, the faster the compression. Okay? General solution is y equal to what? E to the power 3x times minus this. Okay? Then we have what? Minus becoming plus. Then we have 1 over 3 e to the power minus 3x and then plus c. So if you like, you can open the brackets. If you like, you can open the brackets. So that's that on this particular question. That's that on this particular question. I want to appreciate you for coming on board, for coming online at this time. Thank you for your support. Okay? But please, let's make this support, let's make it to be massive. Let's make it to be massive. Okay? Don't watch this video alone. Call your friend to join this live section. Forward the links of this live section to your friends and to your friends. Begin to do it right now. Begin to do it what? Right now. Thank you for doing that. The differential equation 2xy over x squared plus 1 minus 2x, the brackets are closed, dx, okay, plus natural logarithm of x squared plus 1, close the brackets, minus 2 dy equal to 0. We have the condition given as y of 5 equal to what? Equal to 0. Okay, so that's what we have in this question to solve the differential equation. This one also is also first order differential equation. Okay, this one is also first order differential equation. I'm not leaving. I'm here. I'm not leaving. We still have questions to solve. Okay, we still have questions to solve. Thank you for coming on board. Thank you for coming on board. Thank you, thank you, thank you. What we are going to do to this question, when you have an equation with the x, another equation with the y, okay, we need to look at the forms of the differential equation. I mean, first order differential equation. Which one does this equation conform to? So this conforms to m as a function of two variables, x and y, dx, plus what? N as a function of x comma y equal to 0. Okay? This follows exact differential, but we don't know whether it's exact or not. So we want to test for the exactness of these differential equation. And how do we do that? How do we know the differential equation is exact or not? How do we know that? How do we know that? Okay, I'm going to show to us how to get exactness of differential equation. Okay, please bombard this live section with I. Okay, I can see you. You can also see me. Okay, begin to show love to this video. I want the love sign to be flowing on this live section. Begin to show like to this video. Okay, and begin to type your comment. Say something. Say something. I'm saying something to you that I like. I appreciate you coming on this live section. You also say something. Okay, I like your energy. I appreciate your dedication. Say something. Let's make this section interactive. Okay, communication is in two ways, from the sender to the receiver. Say something. Say something. Begin to type something now. Hello, hi. Say I as you're coming in, and subscribe straight away. Subscribe to this channel straight away. Do it right now. Do it right now. Thank you. Thank you. I can see the support. Let's make it massive. Let's make it massive. Thank you. Thank you. Thank you. So in that case now, my m is this. This is my m. The attachment to the x is the m. The attachment to the what? To the x is the m. And that's what? 2xy over x squared plus 1 minus 2x. The attachment to the y is the n. My n is what? Natural logarithm. X squared plus 1 minus 2. This y. And that will be 1. So I'm having 2x over x squared plus 1. And this one, this minus 2x, there's no y there. So that will become 0. It's as if you are differentiating an integer. Okay? If you want more videos on partial differential, okay, we have a lot of videos on this channel. Check my playlist on partial differential, okay, for more elaborate discussion. Okay, thank you for doing that. Thank you for doing that. Let's go to the partial differential of n. You're going to differentiate n partially respect to the other function, respect to x. Okay? You differentiate the n respect to the other function, respect to n, respect to x. Look at the function we have. We have a natural logarithm. Natural logarithm. How do you differentiate that? Very simple answer to that question. You take the composite function, the inner function, you differentiate that respect to x, and that'll be what? That'll be 2x, okay, over the function itself, that's x squared plus 1. Okay, let me repeat myself again. When you are differentiating natural logarithm, you differentiate the inner function over the function itself, and that's how to differentiate natural logarithm. The constant here is 0, okay, and if you check now, the first partial differential, the second partial differential, you realize that they are equal, and that shows that the equation is exact. Partial differential of m respect to y is equal to what? Partial differential of n respect to x. This is what? This is exact. This is exact. And when an equation is exact, is that the end of the road? Capital no. Okay? Because we want to find the what? The solution. Okay? It connotes that there is a function f. There is a function f as a function of x and y, such that partial differential of f respect to x is equal to what? Is equal to m. Okay? Okay? And at the same time, partial differential of f respect to y is equal to what? Is equal to n. So you can use any of these two to get the general solution. You can use any of these two to get the general solution. You can use any of these two to get the general solution. Thank you for coming on board. Thank you for your cooperation. Thank you for your cooperation. Thank you for coming on board. As you are coming in, just say I. Just say I to this and begin to show love to this video. Begin to show love to this video. Begin to show love to this video. So from where we stop, you can use this one to get a general solution. You can as well use the second one to get the general solution. The choice is yours. I'm going to use the first one to generate the general solution. I'm going to use the first one to generate the general solution. And that will be equal to integrate both sides. We're going to have f equal to integral of m as a function of x comma y dx. You can use dx or you can use del x. Okay, but what we are going to do here is partial integration. Okay, and when you are integrating respect to x, you're going to have an arbitrary constant which we call g of y. You're going to have an arbitrary constant which we call g of y. Okay, let's make a substitution for m. My m is what? 2xy over x squared plus 1 minus 2x. That's my m dx. Okay, and then plus g of y plus g of y plus g of y. I want to tell you these are past exam questions. These questions, they are past exam questions from one of the schools. Okay, these are past exam questions. Okay, these are past exam questions. Um, so that's what we have there. That's what we have there. Then let's now look at this. Let's look at this. We want to integrate respect to x, and then we have integral of what? Difference of function. Integral of difference of function, which will be equal to integral of this y is a constant. You can take it outside, and that will be 2x over x squared plus 1, and then minus 2x. Okay, integral of 2x dx. When you have integral of sum of functions of difference of functions, it's going to be integral of each of those functions. It's going to be integral of each of those functions. Don't forget the dx here. Look at this one. The derivative of the denominator is 2x, which is equal to numerator. And that will be equal to what? Y equal to what? Y times natural logarithm of what? Of the denominator. Natural logarithm of the what? Of the denominator. Okay? And then minus here, that will be 2x squared over what? Over 2. This is power 1, so plus 1. Plus 1. Don't forget, if you want to integrate x to power n dx, it's going to be x to power n plus 1 over n plus 1, and that's what we have done in this case. That's what we have done in this case. As you're coming in, begin to say I. Begin to say I. Say something. Say something. Begin to say I. Thanks for the likes. Thanks for the likes. Okay, call your friends. We are still solving questions on first order differential equation. We are using separable techniques. We are using Bernoulli, and we are using exact differential equation. These are the methods to solve first order differential equation. These are the methods to solve first order differential equation. Thank you, thank you, thank you, thank you. This one, these two we cancel. These two we cancel. Don't forget the g of y plus g of y. So we now have now f equal to what? F equal to y natural logarithm of this minus x squared plus g of y. Okay, this is our equation, but we need to find the g of y. We need to find the arbitrary constant, the g of y. And to do that, you differentiate that equation, partially with respect to y. With respect to y. With respect to y. Differentiate that equation with respect to y. So we are going to have partial differential of f respect to y, and that is equal to n. That's equal to n, and my n is equal to what? Natural logarithm of x squared plus 1 minus 2. That's my n. Okay, equal to differentiate this one partially. You're keeping natural logarithm as a constant. You are differentiating the y only respect to y. So that would be what? A natural logarithm of x squared plus 1. And then if you differentiate x squared is a constant, then you have what? G prime of y. And I've told us from the intro that at this point, something must cancel. This one and this one cancel each other. It cancels each other. So we now have we now have now um, g prime of y is equal to minus 2, and then integrate both sides. Integrate both sides, then we have integral of what? Minus 2 dy, and that will be equal to what? Minus what? Minus 2y plus what? Plus c1 plus c1 plus c1 plus c1. So we now go back to this equation and substitute the g of y. So f is equal to y times natural logarithm of x squared plus 1 minus x squared, okay, plus my g of y is equal to minus 2y, which will cancel this plus what? Plus c1. And don't forget the condition given, y bracket 5 is equal to 0, equal to 0. What is the meaning of that? What is the meaning of that? Okay, the meaning is that when x is 5, y is equal to 0. And don't forget f is equal to what? Is equal to c. F is equal to c. Then you can combine this one and this one together. Okay, so you now have this one. Okay, you have this minus x squared minus 2y equal to capital C. Let's make substitution. X is 5. Let's make substitution and get the C. My x is 5. That will be natural logarithm of actually y is 0. This cancel. So we have what? We have here minus 25. Okay, this one also cancel. Okay, so that is what? That is the C value. That's C value. So just come back to that equation and plug in your C. Come back, plug in your C. The final conclusion is equal to this one plus 1 minus x squared minus 2y equal to what? Minus 25. And that is the answer to that question. That is the answer to that question. That is the answer to that question, and that is the final conclusion to that solution. X equal to 2 times, open your brackets, natural logarithm of x plus 1, close the brackets, over sine x plus what? Y cos cos y, y cos y. So if you look at this is first order differential equation, okay? And if you look at this conform to this expression. It conforms to this expression, f of x times g of y. The y dx equal to what? F of x times g of y. If we check the right hand side, it contains 2 functions, x variable or x function and what? And y function. Okay, and that will call for what? Separable techniques. We're going to separate the variable. So once your differential equation follow this format, then the techniques to use is to separate the variable. Okay, to do what? To separate the variable. Once it follows this format, that is the next thing to do. Okay, so to do that, we're going to cross multiply, and that will be equal to sine y plus y cos y, close the brackets, dy, okay, equal to 2 into brackets natural logarithm of x, okay, plus 1 Okay, close the brackets, and then the x. So we've separated the variable y function on the left side, the x function on the right side. Okay, that's what we have done so far. That's what we have done so far. Okay, please, as you are coming in, say hi. Greetings to you. Greetings to you over there. Okay, good evening, and please subscribe. Give this video a thumbs up. Give this video a thumbs up, and see here for this live section. Okay, thanks for coming online. Thanks for staying by. Okay, subscribe to the channel. Share the links of this video on your social media platform. After you separate the variable, then introduce your integral sign to both sides of the equation. Introduce your integral sign to both sides of the equation. And don't forget, when you have integral of sum of function, integral of sum of function, integral of sum of function is going to be integral of each of those functions. Integral of difference of function is going to be integral of what? Each of those functions. Okay? So going to be integral of what? Integral of sine y, okay, dy, plus y cos y dy. Don't forget the integral. This one here is a product rule. Let u be equal to what? Y. So the u is equal to what? The y. And then the v is equal to cos y dy. Integrate this place, and that will be v equal to what? Sine y. Let's do this one also. Let's do this one. This will be equal to 2 times derivative of the inner function is 1 over the function itself. Don't forget the x here. Okay, and then plus what? Plus 2x, and then finally plus what? Plus c. So we now have sine y plus uv, this one, that's what? Y sine this, minus integral of what? Integral of v, which is the sine y, and then the what? The u is what? The y. Okay, I use this equation, uv minus integral of v the u. So that's what I use, equal to what? Equal to 2 over x plus 2x and then plus c. For final conclusion, we have sine y plus y sine y. If you integrate sine y, it's going to give you minus cos. So that will be plus cos y equal to 2 over x plus 2x plus 1. So that's what we have in this case. Okay, that's what we have in this case. I want to appreciate you for staying by. Okay, I want to appreciate you for watching my videos. Okay, thank you for coming on board. Thank you.